Hello everyone. Today we are going to discuss about representation of a graph. Graphs are used to represent many real-life applications such as networks, and networks may include paths in a city or telephone networks or circuit networks. Graphs are also used in the social networks like LinkedIn, Facebook, etc. In a Facebook, each person is represented with a vertex or a node, and each node is a structure and contains the information like person ID, name, gender, and locality. There are two most commonly used representation of a graph. First one, adjacency matrix, and second one, adjacency list. Adjacency matrix we have already discussed in the previous lecture. Now today we are going to discuss about adjacency list, that is how to represent a graph using a adjacency list. Now let us understand this adjacency list considering this small example of an undirected graph where there are 5 nodes, 1, 2, 3, 4 and 5 nodes, or you can say vertices. This graph is represented in the adjacency list. Now to write the adjacency list or to represent by using adjacency list, we need to first write down all the main vertex, that is 1, 2, 3, 4 and 5. And considering each main vertex, we need to see how many adjacent vertex are there for that particular node. For example, if you consider this first node, for this first node, node 2, node 3 and node 4 are the adjacent nodes to this one. So we write this 2, 3 and 4 as the adjacency list of node 1. Similarly, if you consider 5, fifth vertex, then for this fifth vertex, node 3 and node 4 are the adjacency, or you can say adjacent node. So 3 and 4 becomes the adjacency list for node 5 or vertex 5. So this is how we represent the adjacency list for a given undirected graph. This representation can also be used to represent a weighted graph, but in case of a weighted graph, the weights of edges can be represented as a list of pairs. This is the adjacency list for a directed graph, where you can see all these main vertices or nodes 1, 2, 3 and 4 are written here, and corresponding to each vertex we need to write which are the adjacent nodes. Now for this 1, 2 and 3 are the adjacent nodes, so we write it here as 2 and 3. And next there are no nodes, so we write it as a null value. So this is how we obtain the adjacency list for a directed graph and an undirected graph. So this is another example I consider. This is a directed graph and its node list and the adjacency list. Now if you see here, for node A, B, C and D are the adjacent nodes of A. So we write this B, C and D as the adjacency list for the node A. Similarly, if you consider E, there is only one adjacent node or adjacent vertex, that is C. So we write it as a C as the adjacency list. Now to represent this graph using link representation, we need to consider two lists. One is a node list and second one is a edge list. In case of a node list, there are three fields. First field is called as a node, which represents the name or a key value of a node. Next field is called as a next, a pointer to the next node in the node list. And third one is called as an adjacent. Adjacent is a pointer to the first element in the adjacency list of the node, which is maintained in the list edge. In the edge list, the first field is called as a destination, and the destination will point to the location in the node list of the destination node of the edge, and second field is called as a link. It will link together the edges with the same initial node, that is the nodes in the same adjacency list. Now we will understand this node list and edge list, how to write down the node list and edge list considering the previous example. So I have this previous example over here. This is the directed graph and its adjacency list, where the different nodes are there and adjacency list is there. Now to represent this by using a link representation, let us consider the first node A and its adjacency list as B, C, and D. Let's see how to write this node A and adjacency list as B, C, and D. This is how the schematic diagram of a link representation look like. First we'll have the node list and the edge list. In the node list, all the main nodes will be available here, that is A, B, C, D, and E. So if you see in the graph, the main nodes are A, B, C, D, and E. So we have to write here A, B, C, D, and E. So that is the first field in the node list, that is the key value. Second field is, if you see here, the second field is the next field, which is nothing but it is a pointer to the next node in the node list. So that means the second field will have the address of the next node in the node list. The next node in the node list is B, so it will have the address of B node over here. And the third list, if you see here, in the third field, it is called as the adjacent field, and it will have the address of the first node in the edge list. So in this case, the address of the first node in the adjacency list is B. So that means this particular field will have the address of B. So address of B will be present over here. Now next is the edge list. In this edge list, if you see here, in the adjacency list, B, C, and D are the adjacent nodes. So in the edge list, this will represent B, this will represent C, and this will represent D. So this will represent B. Address of this B will be present over here, and address of B will be present in this particular field. The next field will have the address of C. So address of this will be present over here, and this field will have the address of C, because this element represents C. This element represents D. Therefore, this will have the address of D, and the last field will be marked with a 0 because there is no other adjacent node. So that is why we mark with a 0. So in the same way, we obtain the node list and edge list considering all other main vertices, that is B, C, D, and so this is how we represent the link representation of an even graph. This is a simple example where the graph can be represented with the help of a node, next, adjacent list, and destination and link list. The start and avail will tell you which is the starting vertex and which is the how many free memory locations are available considering the avail list.